All right, so we're going to walk through some examples of using the TI-83, 84 calculator, math of finance functions in order to calculate problems for compounding interest and things like that. Now, depending on the rules around your particular professor or your class, you may still need to be able to show how to use the formulas, but in those cases, you can still use this process to check your answers, or your instructor may have an emphasis on using the calculator. And so then you'll, like for myself, I know that if my students use the math of finance functions, I want to see them write down like what did they enter into the calculator so that I know like where these numbers are coming from, rather than just poof, they show up. Now, different calculators, the 83, 84 models will have the math of finance function in slightly different places depending on the age of the calculator. So in some calculators, you will have the math of finance function. Um, there will be an apps function above the x to the -1 key. This is my really, really old calculator, my old 83. In some calculators, there will be a program menu. Um, in more recent calculators, there's an apps function. On my 84, it is next to the math button. So you might need to look under programs if it is, which is again next to the apps key on my 84. If it's something you've downloaded, um, or like transferred from another calculator, or it's under the apps applications tool. There is a finance function there. And when you find that finance option and you click on it, you should get a screen that looks like this. So again, different calculators will have this finance options in different places, but in most calculators in the last 20, 25, 30 years, this is a default thing that does appear. You don't have to necessarily download it. It should be in there. Now, if you do have an older calculator that doesn't have it in there, you can, in some cases, download it either from another calculator or from the TI website, if your calculator has that functionality, and or you have your like connector cords to connect calculators together. Now, once you find that finance program and you click on this screen, we're going to use the TVM solver to do these examples. And when you click on it, if you've never used it before, you'll get a screen that looks like this. It'll be filled in with all these zeros and everything. That's fine. We're going to fill these values in as we do our examples. Now, just to understand what is going on here, N is the total number of compounding periods for the calculation. So in our the previous video on Math of Finance, where we were working through problems using the formula, this is equivalent to the M, or it is N times T. So it's the number of periods per year times the number of years. So capital N here is the total number of compounding periods. I% is the interest rate in percentage form. So in using the formulas, we had to convert to decimal. But for this calculator, that percent conversion is already included in the function. And so you would enter the percentage form. So if the interest rate is 4%, you would put a 4, not 0.04. PV is the present value. So that typically that's the principal in most of our equations. PMT is the payment. In our payment formulas, that was represented by an R. Future value is usually either A or S depending on the formula. So it stands for the amount, or the amount in savings, or the sinking fund amount, whatever you want to think of it as. And then PY is the payments per year, and CY is the compounding per year. This is N in our equations. In all of our examples, and PY and CY are identical. And so if you change PY, CY will change automatically. in principle, you can have PY and CY be different values, but you would have to change PY and then change CY. That's generally not what is done in any of these problems. You generally want to make payments at the same rate that you are compounding for these examples. And then PMT, end or begin, is going to determine whether interest is earned at the end of the period or at the beginning. Now, in some problems, there will be a specific type of annuity called annuity due. And in those, you will get interest at the beginning of the period. But all the other examples will use end. So if in doubt, put end. And again, end is the default in any case. Now, there's 3 of these options on our screen: PV, PMT, or FV. PMT, FV, or PV. We generally only use 2 of these 3. So typically one would be 0, we would fill in the other one, and then we would solve for the third one. So that is something to kind of keep in mind. You don't need to fill all of these in. If you're not using it, make it 0. And you can do calculations on screen. So if you have monthly payments for 7 years, you can type 12 times 7 and the calculator will convert the value to you. Now, there is a bit of a quirk with these formulas that actually also shows up in Excel, and this is probably an accounting thing. But when it does calculations on any of these payments, present value or future value, one of the values will typically come up as negative. Now, you can ignore these values for our math of finance formulas. They are designed not to come up negative. However, in some cases, you will have to enter one of them as negative if you want to solve for N or I%, or the interest rate. So otherwise, it won't come out right if you don't do that. So let's look through some examples and see how this works on our screen. So suppose you want to save money. This is from example 2. You want to save money for a down payment on a house in 2 years. You have $10,000 of bonus money in a CD earning 11% annual interest. How much money will be in savings for the down payment when the CD matures? So the N is going to be weekly compounding times 2 years, so 52 times 2. That will convert to 104. The interest rate is 11%, so that goes as 11 in the I%. The present value, that's again typically the principal, it's the amount of money you have right now. The present value will be the loan amount, or it will be the amount that you're investing and then letting sit there, which would be the $10,000. We're not making any payments on this. Our payment rate and our compounding rate are 52 because it's weekly. Now here we're not making any payments, we're just getting compounding, but they're the same value. And then after we enter all of these values, then the solver option is above the enter key. Hit alpha. The alpha key is on the second row of your main keypad on the top left. And then the enter key is obviously on the bottom right. And so alpha enter will get you the solve function, and it will solve for whatever line your cursor is on. So move your cursor to the future value, since that's what you're calculating for, and that will calculate your balance. Now notice that this is the same value that we got in the actual example 2, except that there's a negative sign in front of it. Again, you can ignore the negative sign and then round your answer to the nearest penny. Now we can walk through example 6 again, but now with the calculator. Again, see my other math and finance video for doing the formula for this problem. So I wish to purchase a car that is sticker priced at $15,000. I can get a loan for 5% with the credit union. How much money will I have to pay each month if I take out a loan for 5 years? So N is 5 times 12, so that's 60. Our PY and CY is 12 because our payments are monthly. Reset the future value to 0 because at the end of the loan, we don't want there to be any money left. And then the present value is the amount that we're taking out in the loan. That goes here as 15,000, and the I% is 5 since it's a 5% loan. And again, if we run the solver, we'll scroll to the payment line and then hit alpha enter. That'll solve it. And again, notice that you get this negative value, but it is the same value that we got before if you round to the nearest penny. Now, this is the sinking fund example. It's the savings amount. So I'm setting aside a certain amount of money. I have a certain amount of money now. I'm solving for a certain amount of money in the future. And so I want to plan for this. How much interest do I have to earn in order to get my 8,500 to turn into 10,000? So $10,000 needed for a down payment. That's the future value. I have only $8,500 now. What annual interest will I need to get to save in the allotted time in 5 years? Annual, since we're compounded annually, we're just going to put in 1 for our PY and CY. Our N is 5. If we're getting annual interest, that's 1 times 5. We're going to put in our 8,500 for the present value and 10,000 for the future value. And if you go ahead and calculate that, you'll actually get an error because it's expecting that one of these values is going to be negative. And so if you change one of these values, either the future value or the present value, it doesn't matter. I made the present value negative. And then if you go to the I line and you hit solve, again, payment is set to 0 here. But if you go to the I line and then you hit the solver function, second alpha, then this is going to come up with the answer that we got when we did this problem with the by hand formula, the 3.3%. Now, again, you can change this and you can check. If you make the future value negative and the present value positive, you will get the same thing. So it doesn't matter which one you make negative as long as you make one of them negative. So how long does it take to double an investment if I am earning 10% compounded quarterly? So this is a problem that does sometimes come up, and you can solve it using the previous compounding interest formulas, but we'll solve this one with the calculator. So compounded quarterly, we're going to put our PY and CY to be 4. We know that we're earning 10%, so that goes there. And we want to double the amount. Now, they didn't specify what that was, but we can put in 1 for the present value and 2 for the future value. And again, we want to make one of them negative so that the calculator will work. And then scroll up to the N line and hit your alpha enter to run the solver. And what you get is 28.07. Again, this is the number of compounding periods. So this is 28.07 quarters. That would mean we actually technically need 29 quarters because 28 is not quite enough. So that would be 7.25 years. Again, this is a problem you can do this calculation for using just algebra. But solving for N usually involves, like similar to solving for T, you have to use the log rules and things like that in order to get access to that exponent. And here, the only thing you have to remember is to just make your one of your present value and future value, not both of them, but one of them negative.